Welcome to Baja Collective. Leading you on this journey, I'm your host, Evan, along with.
Brandon,
And Katie.
Today, we're diving into the fascinating work of Dr. Joseph Graves, a trailblazer in evolutionary biology whose career and research span topics from systemic barriers in academia to groundbreaking studies on nanomaterials, bacterial resistance, and race in medicine. For the past few weeks, we've explored Dr. Graves' diverse contributions and their significance not only to science, but to society. Graves' journey as the first African American to earn a PhD in environmental, evolutionary, and systematic biology is a remarkable testament to his dedication and resilience. His story, as told in Belly of the Beast, reveals the deeply rooted systemic barriers Black scientists face in academia. These obstacles are not always overt, but are embedded in the unwritten rules that govern the academic world, such as biases in hiring, publication, and funding opportunities. These subtle yet pervasive barriers make it harder for underrepresented groups to thrive, often hindering their career advancement and contributing to a lack of diversity in scientific research. Despite these challenges, Dr. Graves' persistence has been a beacon of hope and motivation for other aspiring scientists of color. His commitment to groundbreaking barriers and his role as a mentor to others highlight the importance of creating equitable opportunities within science.
Dr. Joseph L. Graves is renowned in evolutionary biology and race studies with an extensive career spanning academia, research, and public advocacy. For example, his CV includes notable positions such as Professor of Biological Sciences at North Carolina A&T State University and contributions to groundbreaking research on genomics, evolutionary theory, and the intersection of race and science with numerous publications and involvement in national science policy discussions. Additionally, his research blends science and social justice to challenge conventional wisdom, promote equality, and advance our understanding of the natural world. One of the most inspiring aspects of Dr. Graves' works is his interdisciplinary approach. He bridges the gap between two fields often seen as separate, evolutionary biology and social science. In his book, Racism, Not Race Answers to Frequently Asked Questions, co-authored with Alan Goodman, Dr. Graves argues that race is not a biological fact, but a social construct. This is a powerful challenge to the traditional views on race that have been well established in science and society. What makes this argument so compelling is not just its theoretical basis, but its practical implications. Dr. Graves highlights how the concept of race has been misused throughout history to justify inequality and discrimination. His work encourages us to rethink the science behind race and move towards a more accurate, socially responsible understanding. Another interesting aspect of Dr. Graves' research is his work on rapid evolution, specifically the evolution of silver nanoparticle resistance in E. coli. In the study, Dr. Graves and his team demonstrated how bacteria can quickly evolve resistance to emerging technologies like silver nanoparticles, which involve significant implications for medicine, public health, and environmental science.
Dr. Graves' research on nanoparticles explores the intersection of biology and technology, emphasizing their potential and risks. In the safety of nanoparticles, what we know and what we need to know, he calls for safety studies on nanoparticles, widely used in products like cosmetics and medical devices. Their nanoscale size enables them to penetrate biological barriers, causing oxidative stress, DNA damage, and ecological disruptions. However, their rapid commercialization has outpaced understanding of long-term impacts. Chronic exposure to nanoparticles can drive evolutionary pressures such as bacterial resistance, reducing their effectiveness as antimicrobials, and in rapid evolution of silver nanoparticle resistance in Escherichia coli. Graves showed how E. coli developed resistance through genomic mutations after 225 generations. He also advocates studying nanoparticles with model organisms like Drosophila, revealing how populations adapt to selective pressures and providing insights into evolutionary toxicology. Graves's work It highlights the importance of understanding evolutionary dynamics to predict and mitigate unintended consequences of new technologies with implications for health, agriculture, and medicine.
The study Genomics of Parallel Experimental Evolution in Drosophila attempted to find the adaptation of 30 different populations of fruit fly Drosophila to three different regimes of selection over hundreds of generations. Such selection pressures result in remarkably parallel evolution of the response among those populations at both a phenotypic and genomic level. Instead, adaptation in these sexual populations was dominated by shifts in the frequency of standing genetic variation, rather than by selective sweeps much more common in asexual organisms. Unexpected congruence of linkage disequilibrium, indicative of rapid, pervasive adaptation on a genomic scale. These findings have shown that sexual populations can respond to selective pressures in a reproducible way, to give an overview of genetic causes of adaptation.
Dr. Graves critiques racial medicine evolutionary versus racial medicine, contrasting it with the evidence-based framework of evolutionary medicine, which identifies five primary causes of disease: infection, novel environments, genetic factors, design compromises, and evolutionary legacies. He emphasizes that human biology, shaped by millennia of evolution, interacts with modern environments to produce health outcomes. In contrast, racial medicine erroneously assumes biological races exist and attributes health disparities to genetic differences, overlooking the continuous nature of human genetic diversity, which correlates with geographic distance rather than race. Dr. Graves highlights that health disparities are better explained by social determinants like access to healthcare and environmental exposures. He critiques practices such as Bidel, the first race-specific drug, as scientifically unfounded due to flawed trials excluding other racial groups. Advocating for a model shift, Dr. Graves calls for addressing health disparities through evolutionary biology and tackling the socioeconomic inequalities driving these issues.
Now, not everyone agrees with Dr. Graves' conclusions, which makes his work so compelling. His stance that race is a social construct may be difficult for some to accept, especially in a society where race is often discussed in terms of inherent genetic differences. But this is where Dr. Graves' perspective is truly transformative, as it challenges us to separate scientific facts from the harmful myths perpetrating inequality. Another criticism that might be some of his technical research, like his work on bacterial evolution or nanomaterial safety, can be difficult for the general public to fully engage with. The highly specialized content might seem uninteresting or inaccessible to those outside of evolutionary biology or environmental science. However, it's essential to recognize that these research areas are critical to solving some of today's most pressing global challenges. Dr. L. Graves's work stands out not just because of its scientific innovation, but because of its ethical and social relevance. He's a pioneer in the way he connects evolutionary biology with the fight for social justice, and his research offers a powerful reminder that science should not only seek to understand the world, but to also improve it.
Dr. Graves' career is a powerful example of how science can intersect with social advocacy. His work not only advances our understanding of evolution, but also challenges systemic inequalities in academia, healthcare, and society. From his candid reflections on navigating racism in science to his groundbreaking research on nanotechnology and adaptation, Graves' contributions inspire a more inclusive and interdisciplinary approach to biology. For aspiring scientists, his story underscores the importance of resilience, mentorship, and community. By breaking barriers and paving the way for future generations, Dr. Graves demonstrates that science thrives in diversity, not just in the natural world, but within the scientific community itself. Thank you for joining us on BioChat Collective. We hope Dr. Graves' inspiring journey motivates you to explore the intersections of science, equity, and innovation. Until next time, keep questioning, keep learning, and stay curious.